The morning air on Red Beach carried the sharp report of rifle fire, a sound unlike anything Japanese forces had encountered at such intensity. October 20th, 1944, marked a turning point in the Philippine campaign, not through grand strategy or brilliant maneuver, but through the simple mathematics of firepower. American soldiers advanced with weapons that could discharge 8 rounds before requiring a reload, maintaining a pace of fire that left their opponents struggling to respond. The Japanese defenders, equipped with rifles requiring manual operation between each shot, found themselves facing an opponent who could maintain continuous pressure without the vulnerable pauses that had defined combat for generations. This wasn't merely an advantage, it was a fundamental reshaping of battlefield dynamics that would echo through the remainder of the Pacific War. The weapon creating this transformation had its origins not in wartime urgency, but in the methodical peacetime development that characterized American military innovation. More than a decade before conflict erupted across the Pacific, designers and engineers in Massachusetts were solving problems that had frustrated firearms experts for generations. The challenge was deceptively simple in concept, but extraordinarily difficult in execution. Create a rifle that loaded itself after each shot while maintaining the reliability, accuracy, and durability demanded by military service. Previous attempts across multiple nations had produced weapons too complex for field conditions, too fragile for combat stress, or too unreliable for soldiers to trust their lives to them. French designers had tried. Mexican engineers had attempted solutions. American inventors had produced prototypes. All had fallen short of military requirements. The breakthrough would come from a Canadian immigrant whose understanding of mechanical systems and patient refinement would produce something genuinely revolutionary. John Garand arrived at his solution. Through years of testing and modification, his design employed escaping propellant gases to drive a piston system that automatically cycled the rifle's action. When a cartridge fired, a small portion of gas was redirected to power the mechanism that ejected the spent casing, loaded a fresh round, and prepared the weapon for its next shot. The entire sequence occurred in a fraction of a second, faster than any soldier could manually operate a bolt-action mechanism. The technical specifications revealed capabilities that would prove decisive in combat. The weapon measured just over 43 inches in length and weighed slightly under 10 pounds when unloaded. It fired the .30-06 Springfield cartridge, one of the most potent rifle rounds in military service, capable of accurate fire beyond 500 yards. But the revolutionary aspect was the rate of fire. A trained soldier could deliver 40 to 50 aimed shots per minute, compared to perhaps 15 from even the most skilled operator of a manual rifle. This represented more than incremental improvement. It was a multiplication of individual combat effectiveness that would transform tactical calculations at every level, from individual engagements to campaign planning. The weapon's internal magazine held 8 rounds loaded via a specialized clip that automatically ejected when the last cartridge was fired, producing a distinctive metallic sound that would become iconic. By the time war expanded to include American forces in late 1941, production facilities had manufactured approximately 600,000 of these rifles. This initial quantity gave American units an advantage, though not all formations received the new weapon immediately. Some divisions retained older bolt-action rifles through necessity, but production was accelerating rapidly, and by mid-1943, factories were producing over 100,000 rifles monthly. The final production total would exceed 5 million units, representing one of the most successful military procurement programs in history. Every weapon underwent rigorous testing before acceptance. Proof firing with high-pressure test cartridges verified structural integrity. Accuracy testing ensured proper performance. Function testing involved hundreds of rounds fired under varying conditions. Rifles failing any test were rejected and returned for correction. This quality assurance created confidence that extended from factory floor to battlefield. Soldiers knew their weapons would function reliably under conditions that would defeat lesser designs. The rifle could fire after immersion in water. It operated in Arctic cold and tropical heat. It maintained accuracy after thousands of rounds without cleaning. This reliability under extreme conditions was as important as the weapon's firepower in determining its battlefield effectiveness. Meanwhile, Japanese forces prepared for the defense of territory they had captured earlier in the war. Their infantry carried rifles representing evolutionary refinements of designs from decades prior. The Arisaka rifles, adopted in the early 1900s, were bolt-action weapons requiring manual operation between shots. A soldier had to unlock the bolt, pull it rearward to eject the spent casing, push it forward to chamber a fresh round, rotate it to lock, then reacquire his target and fire. This sequence required several seconds, and during that time, the soldier could not effectively engage targets. Each bolt manipulation meant taking the weapon off target. Each ejection and chambering cycle created a moment when the soldier could not respond to threats. These moments accumulated across engagements, creating cumulative disadvantages that tactical skill could not overcome. Japanese military doctrine had evolved around these constraints. Training emphasized accuracy and fire discipline, with squad leaders controlling when subordinates could fire to prevent ammunition waste and maintain coordination. The spiritual and cultural aspects of Japanese military training stressed the rifle as an extension of the warrior's spirit, a tool through which discipline and courage were expressed. The Arisaka rifles themselves were excellent weapons by earlier standards. The actions were smooth and reliable, capable of functioning under extreme environmental conditions. They could be maintained with minimal tools and continued operating even with worn components. Japanese armories had perfected production, techniques allowing manufacture of thousands of rifles, monthly using relatively simple machinery. But excellence by previous standards could not overcome the fundamental constraint of manual operation. In squad-level engagements, 10 Japanese soldiers with their rifles could deliver approximately 150 aimed shots per minute under optimal conditions. In combat, with stress, movement, and suppression affecting performance, actual sustained rates were considerably lower. Japanese tactical adaptations reflected awareness of these limitations. Infantry tactics emphasized fire discipline and controlled volleys. Mass attacks, often mischaracterized as fanatical charges, were actually tactical responses to firepower limitations. When facing opponents with superior rates of fire, prolonged exchanges favored the enemy, closing distance rapidly and engaging at close quarters where training and hand-to-hand skills might prove advantageous was a logical, tactical choice given the constraints. The Japanese had attempted to compensate through crew-served weapons. Heavy and light machine guns provided automatic fire support, but these weapons required multiple soldiers to operate effectively and became priority targets. Losing a machine gun meant losing the majority of a unit's automatic firepower. American forces, conversely, could maintain high rates of fire even after losing support weapons because every rifleman carried semi-automatic capability. Through battles in 1942 and 43, Japanese commanders documented the problem in reports and assessments. Intelligence documents captured later revealed officers' concerns about American firepower. One regimental commander noted that enemy infantry maintained continuous fire with their rifles, and Japanese soldiers could not match this rate with manual action weapons. When engaging equal numbers in open combat, Japanese casualties were consistently higher. Another assessment observed that American rifles appeared to fire automatically, with each soldier generating fire equivalent to 3 Japanese riflemen. Traditional calculations of fire superiority no longer applied to this opponent. Japanese commanders were identifying the problem clearly, but they could not solve it. Industrial capacity already stretched by naval and aviation requirements could not shift to producing millions of semi-automatic rifles even if suitable designs had been available. The Japanese did experiment with semi-automatic designs late in the war. A rifle based on gas operation principles entered limited production in 1945. But by then, Japan's industrial capacity had been so degraded that only a few thousand were ever manufactured. The vast majority of Japanese soldiers would fight the entire conflict with manually operated rifles designed in the previous century. By October 1944, this firepower disparity had been compounding across hundreds of engagements throughout the Pacific Theater. American forces had learned to exploit their advantage, developing tactics that forced defenders into sustained exchanges where rate of fire decided outcomes. Marine and Army training emphasized aggressive fire and maneuver, knowing that squads could suppress enemy positions more effectively than opponents could respond. The stage was set for the Philippines campaign to demonstrate this advantage on massive scale. Every American soldier waiting to go ashore carried a weapon that could fire as rapidly as he could pull the trigger. 8 rounds before reloading, 40 or more aimed shots per minute. Every Japanese soldier in defensive positions carried a weapon requiring manual operation between shots, 5 rounds in the magazine, 15 aimed shots per minute at best. The development process that produced this decisive advantage had consumed over a decade of testing and refinement. Springfield Armory records document hundreds of test firings under extreme conditions. Prototypes were subjected to temperatures from -40 to +140 degrees. They were immersed in mud, sand, and salt water, then fired without cleaning. They were dropped from heights onto concrete. Each failure led to refinements. Each weakness was identified and eliminated through redesign. The gas-operated rotating bolt system placed the gas operation point far from the chamber, reducing heat buildup and fouling in critical components. The rotating bolt locked into the receiver with multiple lugs, providing secure lockup capable of handling the powerful cartridge's 50,000 pounds per square inch chamber pressure. The trigger mechanism involved multiple small parts that had to function smoothly under combat conditions. Manufacturing, each rifle required precision machining of components to tolerances measured in thousandths of an inch. The receiver was forged from high-grade steel, then machined to exact specifications. The barrel was hammer-forged, rifled with 4 grooves, and carefully gauged for dimensional accuracy. The gas system components required precise tolerances to ensure reliable operation. The logistical infrastructure supporting deployment was equally impressive. Ammunition production facilities required modification. The specialized clip loading system necessitated manufacturing millions of 8-round clips. Training programs had to be developed to teach proper maintenance and operation. Spare parts pipelines had to be established worldwide. Armorer training programs had to be expanded to ensure field maintenance capability. Combat loading procedures were elegant in their simplicity. A soldier pushed the 8-round clip into the internal magazine from the top, and the bolt automatically closed, chambering the first round. After firing 8 rounds, the empty clip ejected automatically, and the bolt locked open, ready for immediate reloading. A trained soldier could reload in under 3 seconds. This speed, combined with semi-automatic operation, meant riflemen could maintain sustained accurate fire at rates previously achievable only with machine guns. The weapon represented more than technological innovation. It represented American industrial philosophy applied to warfare. Where other nations sought incremental improvements to existing designs, American designers and manufacturers had created something fundamentally new. The firepower advantage demonstrated in the Philippines rippled through the war's final year, fundamentally altering defensive calculations and tactical doctrine. Within weeks of the initial landings, reports from frontline units confirmed what military planners had theorized, but never proven at scale. Semi-automatic rifles provided such decisive advantages that they effectively multiplied infantry strength by a factor of 3 to 5 in direct combat engagements. By November, Japanese headquarters in Tokyo was receiving detailed analyses from commanders throughout the Philippines. These reports, later captured and translated, revealed cascading psychological and tactical effects of the firepower disparity. One classified assessment stated that American infantry weapons represented fundamental advantage in all direct engagements. Japanese forces could not achieve fire superiority regardless of tactical position or numerical strength. Conventional defensive tactics were ineffective against this firepower. The psychological transformation was even more significant than tactical implications. Japanese soldiers indoctrinated with warrior codes, emphasizing courage and aggressive spirit, found themselves in situations where these qualities provided no advantage. A brave soldier charging an American position would be cut down before closing to effective range. A disciplined soldier maintaining his defensive position would be suppressed by fire volume he could not match. American tactical innovation accelerated throughout the campaign as commanders learned to exploit their firepower advantage. The technique of maintaining continuous fire while advancing toward enemy positions became standard practice. This tactic, impractical with bolt-action rifles that required soldiers to stop and manually cycle the action, was devastatingly effective with semi-automatic weapons. Defenders faced walls of advancing soldiers, each firing repeatedly, creating psychological pressure that broke defensive cohesion before physical contact occurred. The evolution of squad tactics reflected the weapon's capabilities. Squad leaders learned to orchestrate fire from 8 to 12 riflemen, each capable of sustained rapid fire, creating overlapping fields of fire that made counterattacks extremely costly. The traditional emphasis on machine guns as the primary source of squad firepower diminished. While machine guns remained important, the semi-automatic rifle ensured that squads maintained formidable firepower even when separated from crew-served weapons. This flexibility in tactical employment meant that small units could operate independently, with confidence in their ability to prevail in direct engagements. Medical records from hospital ships treating wounded from the campaign documented another consequence of the firepower disparity. Japanese casualties showed much higher ratios of killed to wounded compared to previous campaigns. Medical analysts attributed this to the volume of fire, with soldiers being hit by multiple rounds in engagements, reducing survival rates. American casualties conversely showed improved survival rates as superior firepower allowed faster casualty evacuation and better position security during medical treatment. The ability to suppress enemy fire while evacuating wounded meant more casualties reached medical facilities in time for effective treatment. The campaign's final statistics told the story in stark numbers. By the time organized resistance ended in mid-1945, American forces had eliminated approximately 336,000 Japanese soldiers, while suffering 62,000 casualties themselves. The ratio, while influenced by many factors including air superiority and artillery support, reflected fundamentally unequal ground combat. In infantry engagements specifically, American forces consistently inflicted casualties at rates 3 to 5 times higher than they received. This wasn't the result of superior training or tactics alone, though those factors certainly contributed. It was the mathematical result of one side being able to fire 5 times faster than the other while maintaining equal or superior accuracy. Japanese attempts to counter the firepower disadvantage grew, increasingly desperate as the campaign progressed. Some units attempted mass nighttime infiltration attacks, hoping darkness would negate American firepower advantages. These tactics achieved occasional local successes, but ultimately failed. American forces adapted by establishing defensive perimeters with overlapping fields of fire, and the rifle's rate of fire remained effective even in limited visibility. Other Japanese units attempted to avoid direct combat entirely, reverting to guerrilla tactics and ambushes. But even these approaches proved ineffective against American firepower. Ambushes require inflicting rapid casualties before the enemy can respond effectively, but American forces could generate suppressive fire so quickly that ambushing units found themselves pinned down and overwhelmed before achieving their objectives. The implications extended beyond the Philippines. Planning for the proposed invasion of Japan incorporated assumptions about firepower advantages that the semi-automatic rifle provided. Military planners calculated that the weapon effectively multiplied infantry strength, reducing numerical superiority required for successful amphibious assaults. Documents from planning staffs indicated that planners believed one American division equipped with these rifles was equivalent to 1.5 to 2 divisions equipped with bolt-action rifles in combat effectiveness. This calculation influenced force structure decisions and casualty estimates for proposed operations that were ultimately never executed. Japanese military leadership recognized the implications. Post-war interrogations of senior officers revealed that many had concluded by early 1945 that conventional military resistance was futile. The combination of American air superiority, naval dominance, artillery firepower, and infantry weapons superiority meant that Japanese forces could not win battles, only delay defeat while accumulating casualties. Some historians argue this realization influenced leadership's eventual decision to surrender. Although the atomic bombings and Soviet entry into the war were obviously decisive factors, the recognition that continued resistance would only multiply casualties without changing the ultimate outcome may have contributed to the acceptance of surrender terms. The weapon's influence extended into the post-war era and subsequent conflicts. The rifle served as standard American infantry equipment through the Korean War, where it again demonstrated decisive advantages against opponents equipped with bolt-action rifles and early semi-automatic weapons. Veterans of both World War II and Korea consistently rated it as the finest infantry rifle of its era. One general's assessment, calling it the greatest battle implement ever devised, became the weapon's enduring epitaph. This wasn't hyperbole from someone unfamiliar with military equipment. It was the considered judgment of a combat commander who had observed the weapon's performance across multiple campaigns and theaters. The technological lessons were absorbed by military establishments worldwide. By the 1950s, every major military power was developing or adopting semi-automatic or automatic rifles. The bolt-action rifle, dominant for 70 years, was relegated to specialized roles like sniping, where its advantages in accuracy and simplicity remained relevant. The rifle demonstrated that in modern industrial warfare, the side with superior technology and the industrial capacity to deploy it at scale would dominate the battlefield, regardless of numerical strength or tactical positioning. This lesson influenced military thinking and procurement decisions for decades afterward. The human cost of this technological disparity was staggering. Hundreds of thousands of Japanese soldiers died in combat against American forces throughout the Pacific War. Many of them were brave, well-trained, disciplined soldiers whose primary disadvantage was inadequate equipment provided by an industrial base that could not match American production capacity. The rifle saved countless American lives by providing overwhelming firepower advantages. American soldiers returned home who might otherwise have died in more evenly matched engagements. But it also inflicted catastrophic casualties on an enemy unable to respond effectively, raising questions about the relationship between technological advantage and the human cost of warfare. The development of this weapon system involved more than just the rifle itself. It required transformation of ammunition production, development of training programs, establishment of maintenance procedures, and creation of logistical systems capable of supporting millions of rifles across global theaters of operation. The specialized 8-round clips had to be manufactured in enormous quantities and distributed worldwide. Each clip was a precision item, machined to exact specifications to ensure reliable feeding and ejection. The logistics of producing and distributing these clips, along with millions of cartridges, represented a significant industrial and organizational achievement. Training programs had to teach soldiers not just how to fire the weapon, but how to maintain it under field conditions. The rifle was more complex than bolt-action predecessors, with more moving parts and tighter tolerances. Soldiers had to learn proper cleaning procedures, how to recognize worn or damaged parts, and when to seek armorer assistance. Armorer schools trained specialists capable of performing field repairs and maintenance. These individuals learned to diagnose malfunctions, replace worn components, and ensure weapons remain serviceable under harsh conditions. The training, infrastructure supporting the weapon's deployment was nearly as important as the weapon itself. The weapon's reliability under extreme conditions was legendary among soldiers who carried it. Stories circulated of rifles that had been submerged in seawater, covered in mud, or exposed to tropical conditions for months continuing to function reliably. This reliability built confidence that extended beyond simple mechanics. Soldiers who trusted their weapons fought more effectively. They took aggressive action knowing their rifles would function when needed. They advanced with confidence that their firepower would suppress enemy resistance. This psychological advantage complemented the technical superiority, creating synergy between equipment and morale. The distinctive sound of the ejecting clip became one of the most recognizable acoustic signatures of the war. Critics initially argued this sound would alert enemies that the rifle was empty, creating vulnerability during reloads. But combat experience proved that in the chaos of battle, with multiple rifles firing simultaneously, identifying individual reload sounds was impossible. The sound actually became a psychological weapon in some engagements. Japanese soldiers, who had learned to recognize it, sometimes emerged from cover when they heard it, assuming American soldiers were reloading. But other riflemen nearby would still have loaded weapons, making this a fatal miscalculation. The weapon's accuracy at extended ranges gave American forces advantages in open terrain where longer engagement distances were common. The powerful cartridge maintained velocity and energy beyond ranges where lighter rounds lost effectiveness. Combined with the rifle's inherent accuracy and the ability to fire multiple aimed shots rapidly, this made American riflemen dominant at distances where previous infantry combat would have been indecisive. The flat trajectory of the cartridge simplified range estimation and aiming. Soldiers didn't need to calculate complex holdovers for targets at varying distances within effective range. This reduced cognitive load during combat allowed faster target engagement and higher hit probabilities. The weapon's weight and balance contributed to its effectiveness. At just under 10 pounds, it was heavy enough to absorb recoil and facilitate accurate rapid fire, but not so heavy as to fatigue soldiers during extended operations. The balance point facilitated quick mounting to the shoulder and smooth tracking of moving targets. The trigger mechanism provided a crisp, predictable break that enhanced accuracy. Soldiers could learn the exact pressure required to fire and develop muscle memory that improved shot placement. The safety mechanism was positive and easy to manipulate, even with cold or gloved hands. Important considerations in various combat environments. The rifle's effective range exceeded typical combat engagement distances in most terrain. While the weapon could accurately engage targets beyond 500 yards, most infantry combat occurred at much shorter ranges. But the capability for long-range precision fire provided flexibility in tactical employment and allowed engagement of targets beyond the effective range of enemy weapons. The bayonet lug and provision for bayonet attachment maintained capability for close combat. While the rifle's firepower made bayonet charges less common than in previous wars, the capability remained relevant in certain tactical situations. The bayonet itself became primarily a utility tool in many contexts, but its availability for combat was psychologically reassuring to soldiers. The rifle's iron sights were simple and robust, designed to maintain zero even after rough handling. The rear aperture sight provided rapid target acquisition while offering sufficient precision for accurate fire. The front sight post was protected by wings that prevented damage during field use. The weapon's disassembly and reassembly procedures, while more complex than bolt-action rifles, could be mastered with training. Soldiers learned to field strip their weapons for cleaning and maintenance, and armorers could perform more detailed disassembly when necessary. The design balanced accessibility for maintenance with robustness in assembly. The gas system required periodic cleaning to maintain optimal function, but the weapon would continue operating even with significant carbon buildup. The long operating rod design meant that fouling in the gas system didn't immediately affect the bolt and chamber area, allowing extended operation without cleaning in combat situations. The weapon's durability was exceptional. Rifles could fire thousands of rounds before requiring parts replacement. Barrels maintained accuracy through extensive use. The receiver and operating system components were designed for longevity, with generous safety margins in stress calculations, ensuring reliability over extended service lives. The manufacturing, quality control procedures ensured consistency across millions of units produced by multiple contractors. A soldier receiving a replacement rifle could expect the same level of performance as his original weapon. Spare parts were interchangeable between rifles, simplifying field maintenance and repair. The weapon's cultural impact extended beyond military applications. In American culture, the rifle became symbolic of the country's role in the war and the industrial capacity that supported victory. The weapon appeared in films, literature, and art, becoming an icon recognized even by those with no military experience. Veterans maintained deep affection for the weapon that had served them in combat. Reunion gatherings and veterans organizations preserved memories and stories associated with the rifle. The weapon became a tangible connection to wartime experiences and comradeship formed under fire. Collectors and shooting enthusiasts maintain interest in the rifle decades after its military service ended. Original military rifles command significant prices, and reproduction parts allow maintenance of aging weapons. Shooting competitions, specifically for vintage military rifles, include categories for this weapon, preserving skills and knowledge associated with its operation. The rifle influenced subsequent American firearms development. Design elements and operating principles informed later weapons, creating lineage from this rifle through successive generations of military arms. Engineers and designers studied the weapon's strengths and weaknesses, applying lessons learned to new developments. The weapon's adoption as standard infantry equipment represented a significant risk for American military leadership. Committing to full-scale production and deployment of an unproven weapon system required confidence in both the design and American industrial capacity. The success of this gamble validated the decision-making process and encouraged similar bold choices in subsequent military development programs. The industrial mobilization required to produce millions of rifles demonstrated American manufacturing capability. Factories that had never produced firearms were converted to weapons production. Workers who had built civilian products learned precision machining techniques required for military weapons. This industrial transformation was as significant as the weapon itself in determining the war's outcome. The supply chain supporting rifle production involved thousands of suppliers providing raw materials, components, and services. Steel mills produced special alloys for receivers and barrels. Machine tool manufacturers provided equipment for precision manufacturing. Transportation systems moved materials and components between facilities. This industrial ecosystem enabled production at scales that would have been impossible in earlier eras. Quality assurance at every stage ensured that components met specifications before assembly. Receiving inspections verified raw materials. In-process inspections caught defects during manufacturing. Final testing validated completed weapons before acceptance. This systematic approach to quality control was characteristic of American industrial methods and contributed significantly to the weapon's reliability. The training infrastructure supporting the weapon's deployment involved not just individual soldier training, but also institutional knowledge preservation. Technical manuals documented maintenance procedures, part specifications, and troubleshooting guidance. Training films and instructional materials standardized training across different facilities and time periods. The weapon's impact on tactical doctrine was profound and lasting. Infantry tactics developed around the rifle's capabilities influenced American military thinking for decades. The emphasis on aggressive fire and maneuver, the reduced dependence on crew-served weapons for squad-level firepower, and the confidence in small unit capabilities all stemmed from experience with this weapon system. The psychological impact on enemy forces was significant and well documented. Japanese soldiers faced with continuous American fire described feeling overwhelmed and unable to respond effectively. The sustained pressure of semi-automatic fire disrupted defensive coordination and eroded morale in ways that intermittent bolt-action fire had not. The weapon enabled tactical flexibility that previous infantry weapons had not provided. Squads could split into smaller teams while maintaining effective firepower. Individual soldiers could operate independently when necessary, knowing their weapons provided sufficient capability for self-defense and target engagement. The rifle's role in specific battles and campaigns demonstrated its effectiveness across diverse environments and tactical situations. From island assaults to jungle warfare, from tropical heat to Arctic conditions, the weapon performed consistently. This versatility was as important as its firepower in establishing its reputation. The maintenance burden, while greater than bolt-action rifles, remained manageable under field conditions. Soldiers carried cleaning equipment and learned to maintain their weapons during lulls in combat. The weapon's tolerance for less than perfect maintenance meant that it continued functioning even when ideal cleaning wasn't possible. The ammunition logistics required to support the rifle's high rate of fire were substantial. American supply systems delivered millions of rounds to forward areas, ensuring that the weapon's capability could be fully utilized. The industrial capacity to produce ammunition in necessary quantities was as important as the rifle itself. The weapon's effectiveness contributed to American operational tempo advantages. Units could advance more rapidly, knowing their firepower could overcome resistance. The ability to suppress enemy positions quickly and decisively reduced time required for tactical movements, allowing faster campaign progress. The rifle's impact on casualty exchange ratios was documented throughout the Pacific War. In engagement after engagement, American forces inflicted disproportionate casualties while suffering fewer losses. While many factors contributed to this outcome, the firepower advantage provided by semi-automatic rifles was consistently identified as a primary factor. The weapon's reliability under harsh tropical conditions was particularly noteworthy. Humidity, salt air, and mud all challenged weapon systems, but the rifle continued functioning. This reliability in the Pacific theater's demanding environment ensured that American forces maintained their firepower advantage regardless of conditions. The rifle's role in the island-hopping campaign demonstrated its effectiveness in amphibious operations. The weapon could be brought ashore quickly, required no assembly or setup time, and provided immediate firepower for securing beachheads. This capability was crucial in the contested landings that characterized Pacific operations. The weapon's effectiveness in jungle warfare, where engagement distances were often very short and surprise encounters common, validated its design for diverse tactical environments. The ability to fire multiple rapid shots when suddenly encountering enemy forces often determined survival in jungle combat. The rifle's contribution to American victory extended beyond direct combat effectiveness. The weapon's success demonstrated American industrial and technological superiority, contributing to strategic psychological effects. Enemy forces understood. They faced an opponent with both material advantages and the industrial capacity to sustain those advantages indefinitely. The weapon remains today a symbol of American military effectiveness during the Second World War. Museums display it as representative of the infantry, weapons that armed American forces. Historical reenactors use it to authentically portray the period. Collectors preserve it as a tangible connection to history. The lessons learned from the rifle's development and deployment influenced post-war military thinking worldwide. The recognition that future warfare would require high-volume individual firepower drove weapons development across all major military powers. The era of the bolt-action rifle as standard infantry equipment ended, replaced by semi-automatic and automatic weapons. The rifle's story encompasses not just technical innovation, but also industrial achievement, tactical evolution, and human experience. It represents the culmination of decades of firearms development, massive industrial mobilization, and the courage of soldiers who carried it in combat. The weapon transformed infantry warfare and contributed decisively to Allied victory in the Pacific Theater. The human stories associated with the rifle are countless. Individual soldiers developed personal relationships with their weapons, naming them and trusting them with their lives. Veterans returned home with memories of the rifle's distinctive sound, its weight and balance, and the confidence it provided in combat. The rifle's effectiveness in combat validated decades of development work and the decision to adopt it as standard equipment. The gamble taken by military leadership in committing to an unproven weapon system paid enormous dividends in combat effectiveness and lives. Saved, the industrial achievement represented by producing over 5 million rifles in less than 5 years, demonstrated American manufacturing capability at its peak. This achievement in weapons production paralleled similar accomplishments in producing ships, aircraft, and vehicles, collectively enabling Allied victory. The rifle stands as testament to the importance of technological advantage in modern warfare. Superior equipment, wielded by trained soldiers and supported by industrial capacity, proved decisive in determining combat outcomes. This lesson remained relevant long after the rifle itself passed from military service. The weapon's legacy continues through its influence on subsequent firearms development and its place in military history. It represents a pivotal moment when infantry firepower fundamentally changed, reshaping tactical doctrine and combat effectiveness in ways that persist today. The rifle's story is ultimately one of innovation, production, and effective employment combining to create decisive advantage. It demonstrates how technical excellence, industrial capacity, and tactical doctrine must align to produce military effectiveness. The weapon succeeded not just because it was well designed, but because it was produced in sufficient quantities, distributed effectively, supported logistically, and employed by well-trained soldiers who understood how to maximize its capabilities. In the final analysis, the rifle represents more than just a weapon. It symbolizes American industrial and technological prowess applied to military necessity. It demonstrates the decisive impact of superior equipment in combat, and it stands as memorial to the soldiers who carried it, who trusted it with their lives, and who prevailed in the conflicts that defined their generation.